So we got notes 5.1 linear graphs, and we're going to prove solutions. So both of these things we have done before. I don't think we've ever really combined them together. Okay, so we have slope-intercept form, which is y equals mx plus b. Remember that m, right, the coefficient of x, that's always your slope. And we've always known about slope being rise over run. What we've talked about a lot this year is a rise is kind of going up or down, and a run is going right or left. You can look back, way back in chapter 2's notes. They got some rise over run stuff over there if you need a refresher. Y-intercept, right? This is your b value. This is always on the y-axis. This is where we start. Slope is how you get moving, so you don't want to do that one first. Plot your first point, which is this y-intercept. So this level 1 is going to be slope-intercept form and proving points. So I am going to be doing too much. I'm going to be extra about it, mostly so you understand what a solution is for a linear graph, right? Because once we understand what it is, it's easier to identify it and know why that is what's going to work. Okay. The notes video is going to have a lot more examples than what we did in class, so it's up to you if you want to do all the examples from here, or if you'd rather watch this and then copy the ones that I posted in the Google Classroom. Okay, so we got this first problem, right? These graphs are available in class. If not, you can always draw your own. Either works as long as you get it done, you know? So in this first problem, right, we got y equals negative 1/2 x plus 3. Our slope in this problem is that negative 1/2. And we write it how we say it. And then we have our y-intercept is going to be this plus 3. Okay, so I got this from right here. I got this from right here. Now notice how I put the negative attached to the 1 because I only want to use it once. All right, so I always want to start with my y-intercept, right? This is nothing new, but it'll give you a refresher course on this. And then my slope is negative 1/2. So this negative up top tells me to go down. This 2 on the right, or on the bottom, tells me to go right. And from this point, I can go down 1, right 2. And I can do it a couple of times, so I'm going to extend it as far as I can. And now I want us to go in the other direction. So the opposite of going down 1 and right 2 is going to be going up 1 and left 2. And now that we've extended this all the way through, we are going to just draw our line that goes through and makes these dots straight. And if your graph starts to curve a little bit, that means you made a bit of a boo-boo. Okay, so it says we have A. This is a point that's on the line. So this is going to be our A. Now what we're going to do is going to prove if it's true or not. Okay, so we have we're going to rewrite the original equation, which was y equals negative 1/2 x plus 3. All right, what we're going to do is we're going to plug in a. All right, so instead of a y, let me get another color here. Instead of a y, we're going to use that 5 for my point, because that's always your y value. Numbers and symbols don't change, only variables. This is going to be our x value, so instead of an x, now we're going to put parentheses negative 4, and we do that because these two numbers are being multiplied. Then we got this plus 3. And then what I'm going to do is I'm going to simplify each side. Now this 5 ain't got nothing to do, so we're going to kind of keep that 5 how it is. Now on this side, right here, you can use a calculator or a Desmos scientific calculator, whatever you want. I don't have my calculator handy right now, so I'm going to do this old school. I'm going to mental math it. So 1/2 of 4 is 2, and negative times a negative 2, so together this makes 5. So we end up with 5 equals 5. Well, this is true, okay? So all points on a line are true. These are solutions, or if you want to say it's a solution, okay? Now, this is true because, you know, we got this equal sign going on, right? You know, on the next day, we might not have an equal sign. So now let's look at a point that's off the line. So we got 6 comma negative 3. So we got 6 comma 3. So now we got a point that's going to be off the line. All right, that's where this b value is. So let's check this friend out. Let's see what happens. So first we start with that original equation, which was y equals negative 1/2 x plus 3. Then what we're going to do once again is we're going to, but this time instead of a, we're going to plug in the b values, right? So my y value was 3. My symbols and numbers do not change. Only variables change. This x is going to become a 6. And then we got plus 3. Alright, so we're going to simplify now. We're going to evaluate. Sorry, I didn't write that earlier, but in this case we evaluate or we simplify, whatever you want to say. I don't spell evaluate good on the spot, so we're going to leave it like that. So we got 3. Half of 6 is 3, and it's negative, so we got negative 3 plus 3. This is 0. This doesn't work out, so this is false. So points off the line are false, right? They're not going to be solutions. Right? When I say true or false, that means they're going to, be an answer. All right. Now this is again for today because we're talking about equal signs, all right? So we got to be careful about that. We'll talk more about this tomorrow. So let's look at another problem. Right, this time we got y equals 2x. Now in this case, this was kind of weird, right? Because we're missing another number here. Usually we got 2 numbers going on, but in this case we don't. So in this one, I see my slope is this 2, right? Because it's attached to my x. And then for my b value, right, usually we got like something else going on right here. Well, if we don't have nothing, right, there's literally nothing. It's going to be 0. It's not one of those weird invisible 1 things, because usually there's something already there for an invisible 1. So, but in this, in this other case, right, there's literally nothing. Now, before I continue, right, I want to make my slope a fraction. It's not a fraction, so to make a whole number into a fraction, drop a 1 under it. And then I can start graphing this. And once again, we always want to start with our b value. Now we got to plug this as 0 on the y-axis, and that is at the handy-dandy origin. Right? Love the origin. This slope tells me to go up and right, so I go up 2, right 1, all the way through, and then I go in the opposite direction as well. All right. Now I know I did this kind of fast, so if you need to pause, of course, because you're watching a video, you can pause it. But I'm trying to make it not super long. Okay, so letter A, 5, 2. Let's see if that is a solution. Okay, so I got 5, 2. All right, it's over here. Already I know, right? We just figured this out. I already know this is not going to be a solution, but I want to prove it mathematically as well. So I'm going to use that original equation, right? Then we're gonna plug in a, right? So instead of a y, we're gonna use this number 2, and instead of a x, we are going to use a 5. And remember, my number 2 is still there. It doesn't go anywhere. Only variables change. And then I would use my calculator to evaluate this. So we got 2 times 5 is 10, but I don't have a calculator today. So this is false. All right, you can use the Desmos calculator too. It makes fractions a little bit faster for you. All right, next one we got 2, negative 3. So I got 2, negative 3, b. Already, right, we should know off the top of our head this is not going to be a solution because it's not on the point. I'm pretty sure I was trying to make that a solution, but it is what it is. All right, so we got 2x. All right, so once again, right, we start with that original equation. Now we're going to plug it in. Instead of a y, we are going to put that negative 3 here. And instead of an x, we are going to put a 2. All other numbers and symbols remain how they are. Nothing else changes. And I simplify, right? I plug this in my calculator if I need to. Negative 3 is not equal to 4. So again, this is not going to be a solution. This is false. All right, so those are two examples you could possibly see. Level 2, right, we got standard form to slope-intercept form. So standard form is ax plus by equals c. That's like the super crazy way of writing it. All right, to slope-intercept form, y equals mx plus b. So what we're trying to do is we're trying to change this so that the y is over here by itself and everything else is on the other side. So we did a lot of this type of stuff with solving. We just never did it when there were two variables. But if we handled our solving well, you'll do great at this. And I kept them pretty basic, right? We'll level it up throughout this unit. So we got 3x plus y equals negative 2. So what I got to do is I got to move this 3x over here. And we learned in the last unit that if I want to move a whole piece like this to the other side, right, we did this with our single variables, we subtract 3x. And if you do it on one side, you got to do it on the other side. However, this negative 2 is not a like term. So what I'm going to do is I'm just going to write it to like a little bit to the right of it, a little bit away from it so I don't accidentally combine like terms, because we're known for doing that sometimes, and that's okay. So we bring down our y. This negative 2 gets brought down, and minus 3x gets brought down. And again, these aren't like terms, so this is not going to be negative 5x. They are not like terms, so we can't combine them. That's kind of why I wrote this a little bit to the right. All right, we have this now. It kind of looks like slope-intercept form. It's close enough, right? Enough for us to be able to do the things with the math. So we got m, right, our slope. Remember, slope is always attached to your x. So in this case, our slope is negative 3. Our b value is this negative 2 up front, right? My slope isn't a fraction, so let me make it into a fraction. And the only way you do that is if you got a nice whole number that is not a fraction. Drop a 1 under it. We got negative 2. This slope tells me to go down 3, right 1, and I can do that. Only one time though. So what I'm going to do is I'm going to go in the other direction. I'm going to go up 3, left 1 until I can't anymore. Here's my line. It's nice and straight. It's going down. It's doing the things. And it even looks like it's going down. And whenever you see a negative slope, it should look like it's going down. Versus our other example, we had a positive slope, so our line should go up. All right. So we're going to R, A, and B solutions, question mark. So we got 2 comma negative 8. So this one's kind of evil, right? Because there ain't no negative 8 on here. So we got to forcibly do this mathematically, right? It's making us. So what I'm going to do is I'm going to use the one that we figured out. You could use this original one, but we're going to just focus on this one for now. So I got this y equals negative 2 minus 3x, right? Instead of a y, right, I got negative 8. Instead of this x over here, I got a 2. Everything else, though, is going to stay the same, just like that. All right, so I'm going to evaluate this. Negative 8 stays how it is. I'm going to plug this into my calculator or do some mental math, whatever makes you happiest. 2 times 3 is 6, so now we got negative 2 minus 6, which is negative 8. This works out, so this is true. This is the solution. Okay. This next one here, we got 1, negative 3. This is B. All right. We can already tell right away this is not a solution. It is not on the line. However, let's prove it mathematically as well, just for all the haters out there who want to be thinking it is, because they haven't been paying attention to the video. Replace the y with a negative 3. Replace the x with a 1. All other symbols and numbers are going to remain where they're at. Negative 3 simplifies to just itself. Do the mathies that are happening over here. This gives us negative 5. Negative 3 is not equal to negative 5. So we proved that that B definitely is not a solution. And again, we know that from earlier because it wasn't on the line. Number next. All right. We have x plus y equals 4. So once again, this is not in standard form. So all I'm going to do is I have to move this x right over here. And I'm going to do that by subtracting that x on both sides. And once again, I move this one a little bit to the right because they're not like terms. These ones eliminate. We're left with y equals 4 minus x. Now some people are going to be like, Miss R, there's no number in front of this x. Well, I mean, it's that invisible one we talked about. Okay? So just be careful. There was something there, so it won't be 0. So that's where you got an invisible 1. We got a slope of -1 over 1. I changed it to a fraction because we needed a fraction to help us graph. Our b value is that 4. We go to 4. My slope tells me to go down and right. So that's what I'm going to do all the way through. It's going to be a lot because they're kitty corner. And I'm going to go in the opposite direction as well, because we always want to finish out a graph, never leave anything hanging. Connect my line. Okay, we got 10 and -6. That's not big enough for our graph, so we got to prove it mathematically. So I'm going to use this equation that we got up here. Y equals 4, I'll use that minus 1x. All right. Instead of a y, I'm going to stop using colors at this point. No, I won't. Instead of a y, we're going to use this -6. Right? Instead of a x, we're going to use this 10. Okay, I'm going to put it in the parentheses because we've got a coefficient. All right. Simplify using my handy-dandy calculator or my mental math. This works out. This is a true solution. All right, number next, same thing, right? We're going to use that equation again, but instead of a y, we'll use that 7 there for the y value of this point. For the x, we're going to use a -3. I do like to plug in my stuff first. That's a me thing. You don't have to do it that way. Simplify, right? Simplify this using mental math. Please excuse my dear Aunt Sally's or your calculator, whatever is easiest for you or what is allowed for your school. There you go. True. Both of those points, even though they weren't physically on this graph, we figured it out. Oh, actually, just kidding. Point D is right there. There it is. Love that for us. Okay. Last two, quick, easy. They're special cases. Again, we've talked about this before, but we might have forgotten. We got x equals 2. So this one's kind of crazy, right? Because there's no y. Right? There's no y for us to use. And there's no fraction. So all we are know is that x equals 2. Okay, so I'm going to say that again. x equals 2. Okay? So I got to go here. And I don't want to just put a point here, right? Because that's not right. This equation, when you say x equals 2, that means that the line that we draw can only go through this 2. Okay? Now, if I go like this, it's going through every single x value, and that's not okay. We only want to go through the x value of 2. So what we're going to have to do is we're going to have to do a vertical line. Okay? So when you got x equals 2, that is a vertical line. A lot of people mess this one up, right? Because it looks very similar to like our problems before. It just says y equals and then it's got a number. And some people think, oh, this is my slope. Well, that is not the case. All right? Because it's not my slope because there's no x. Right? There's no x. You need to have both for it to be slope-intercept form. If you don't have both, it ain't gonna work. So there's no x here for us to use. So what that means is very similar to this one, right? We know we got y, and we know it's equal to this -3, and that's the only thing that it can be going through is this -3. Let me use red. Right? This is the only thing you can go through is -3. Well, if I am here and I want to go all up and down like I did before, well, what happens is I'm now touching every single y value that is on this line, and that is not what we want to do. So we have to go side to side. That's the only way we can only go through this y value of 3. It's okay. It doesn't say anything about x's, so it's okay if we go through all the x's. But we definitely only want to go through that one y value. All right, so this is one of those horizontal ones. Some people call it a zero slope, which is also fine, right? Because there is no slope. This one would be undefined because you don't even got the y going on. All right, but I like to call them vertical and horizontal. It's a little bit easier. Okay, that's the end of this video. Hope you enjoyed it.